So hi everyone, my name is Bruno. I'm a software engineer at Sentry, and I work mainly with SDKs. And my background is .NET, so I've been working with .NET for a few years. And so I don't have Unity experience other than fiddling around with the platform, with trying to cause errors, catching errors, and understanding how it works under the hood. So from the game developer perspective, I know nothing, and you probably will see through the slides. So maybe we can start with what Sentry is. Sentry is an application monitoring tool. It's also an open source project. So if we go on GitHub, it's there. It's been developed there. All the SDKs are open source as well. Everything we do is out in the open. We can interact with us. We're also online on Discord. So it's like a very open kind of workplace, which is really cool. And if you want to try it out, you can either run it yourself or just create a free account. There are developer free accounts, like up to a few thousand errors per month. It's free. Yeah. So from Sentry perspective, Sentry is an application monitoring tool. It cares about your release builds, right? Like you have your dev tools for development. You open Unity, you can attach the debugger, step through the code. You can write your unit tests. You can do everything you want, like continuous integration, inner ring of tests, the outer ring of tests. You can do whatever you want, but eventually you ship the code to production, and then it will break. It always does. And of course, you can reduce the risk and reduce the amount of errors you have in production, but the truth is that it always fails. That's why we have a business, or Sentry has a business, because there are production issues. So release builds is all that matters. I think this wise man said that once. And with that, I just wanted to say that to prepare that most of the things I'll talk here is from the release build perspective, although there might be some debug builds here as well. So there are lots of platforms that things can go wrong in Unity, and y'all know more than me about this, but I listed the main ones here. So mobile, desktop, console, web. I don't know if web is one of the main ones from like a VR perspective. Not really, right? It would be the headsets. But I just wanted to, put out some platforms here for us to discuss. So one thing that Unity has that will run in all of these platforms is your scripting code. So all the C# code you write will run everywhere in all of these platforms, regardless how technically it runs, it differs, and we will discuss this. But if you, on the other hand, has some native plugin, like some Kotlin file that you throw in your Android app, then that will only run on Android. So as you change the platform, the builds are different, and the types of errors you have also are different. Depending on the scripting engine that you use with Unity, you can also throw in any native code. Like you can put a C file into Unity, and that's going to compile, and it's going to work as well into all the platforms. Okay, so I found this funny. Unity 2016, not that I was building Unity 2016, but it was like simple enough. And today you have all these, ECS game objects, and UWP you had up to 2017 that I remember. UWP was a target, they deprecated it. It was .NET 3.5 or 2.0, and now there's 4.x or Net Standard 2.0. There's lots of options. And if you target Android, then all the Android complexity comes, which API level do you want to target, all these things. So crashing on all platforms, you have C#. With this, you can create bugs that will fail everywhere. It's also my favorite part, having worked with C# for so many years. I really like it. So let's start discussing this. So you write C#, but are you running C#? Like, what do you run at the end of the day? Unity has this API level. Not that long ago, it was 3.5, which was really horrible. 3.5 came out the time I was learning C# in 2007, and up to Unity 2017, that was the standard one. While the world was doing, already .NET Core at that point. And .NET Core, when the project started, they created this .NET standard thing. It's just a set of APIs that different runtimes could implement. Then Mono implemented it, while Xamarin through Mono, and Unity through Mono, and UWP did the same, which is .NET Native and .NET Core, and .NET Framework as well, 4.0. 6.1 retroactively. And they have this .NET 4X, which the first time I look at this, like, but what is this .NET 4.0? Because that's 10 years ago as well, 2010, I think, .NET 4.0. But in their docs, they say it's 4.5, 4.6, and 4.7, and so on. Which is a funny thing. But basically, it's just for compatibility reasons. So if you have a library that you compile for .NET Framework 4.6, then you have to enable this scripting, this compatibility level. Otherwise, you should default to .NET Standard 2.0, which won't introduce, like .NET 4X will introduce a Windows Forms API. You technically could compile something that targets Windows Forms. That would never work on Unity, but it would compile. And with .NET Standard, it's a more cleaner API that's cross-platform. Okay, so what about .NET Standard 2.1? There are 3,000 new APIs. This post is from 2018, and Unity doesn't have it. It would be great to have it. There are new things, .NET Core 3.0 already, 3.1 for sure, support .NET Standard 2.1. But according to Unity, it will come eventually. They hear that people are asking for it, but there are no plans to share at the moment. So, it's great that .NET Standard 2.0 is there, because there's a lot of API. You can build good libraries, good integrations for Unity because of .NET 2.0. But it's clear that Unity kind of lags behind always in terms of adopting new versions of .NET through Mono, because Mono already supports .NET Standard 2.1. So why isn't Unity pulling the new Mono? I don't know. So for the story of Unity developers, and you correct me if I'm wrong, like .NET cross-platform is turning into something really cool. It's rather new, of course. .NET was only Windows, .NET Framework, so it continues to be. But Unity cross-platform, you have the if-defs, so compiler flags of if Android, then you make this platform calls through it. Where in .NET, there is now this cross-platform. .NET, you have the target framework moniker. You can say .NET 5, which is the portable API that will target anything. And you can get platform-specific APIs just by saying this assembly, this project will be .NET 5, Windows 10, yada, yada. Then all that Windows API shows up and it's available for you without you having to put if-def Android or something that you do on Unity. So this is really great, and hopefully Unity will pick these things up as well. Okay, so we got it. Let's get into like crashing ahead of time or crashing compile time. Like we understand that we can get this .NET Standard and we got C# and these things can crash, but how do we do that? Now you have to choose your scripting backend. Is it going to run on Mono or an ILCPP? And these are very different things. Like I think in 2018 there was also UWP, which is deleted. I think we talked about it. And the big difference is here for example, on Android where JIT is supported, Mono is the default, but you can opt into ILCPP. But in some platforms like iOS, ILCPP is the only option. And the reason is you cannot execute writable memory, and it's a security feature, let's call it, that's what they say, from the operating system. So you just have no option. You have to go with ILCPP. And there are some big differences here, and that's why it's relevant. And also, of course, it crashes different. You can have your code that works on a Mono and you change to ILCPP and it's not going to work anymore at runtime. So ILCPP is really the most important one here because you just can't run from it. If you're targeting consoles, you need it, right? But let's start talking about what it does. So it converts .NET intermediate language to C++ code. It's like a transpiler, if you will. It doesn't support line numbers for the managed code, which is a big thing, and we'll talk about it again. Is the only option in some platforms like console, anything that needs ahead of time compiling. And it does manage code stripping, which is also something you have to worry about because it can just delete your code because it couldn't statically find it being used anywhere. So this is the Unity docs. You can see here, manage stack traces with ILCPP. If you can't notice the last little note there, not so clear, I'll make it bigger. ILCPP calls stacks to not include source code line number information in debug or release configurations. But from Sentry perspective, we are a crash reporting tool. Like one of the basic features from our point of view is to give you the function that you wrote and the line number that the thing went wrong, right? So that you can go to your code and find the problem. Of course, there are the trails of breadcrumbs, like, what was happening, the type of the device, hardware, these other things. But at the end of the day, like the line number is a basic thing. If you have a long functions, like you could have happened anywhere in there. It's not great. So what does it look like, the ILTCPP bit? Before we get to that, let's see what a good stack trace looks like. This is a .NET stack trace. I took this the other day playing around with Blazor. This is a WebAssembly. It's a dev build, to be honest. It's not a release build, but it shows you what it's, the release build can look just like this. You just have to symbolicate the crash. And you can see there are line numbers, there are column numbers, right? It looks nice. We have a file path. This was the path in the file system. It goes to the root under the hood. If it was assembly was signed, you see the public key token and the assembly name, everything looks great. And then if you see a Unity monostack trace symbolicated, you get the line numbers, which is great. But I mean, it's a little odd. It's missing, what was the namespace? Like, I don't know. Oh, well, actually the namespace is here. You have the file, but not the file path, just the file name. It's okay. I mean, you can solve problems with this information. It looks great to some level, especially if you compare with an ILTCPP stack trace. You got some function name here with the namespace, but no parameters and no line numbers and no column number and no file name at all. You have these zeros, which would be deleted from the UI so it doesn't look so ugly, but it's not very helpful, right? But today, that's all there is. This is what a raw stack trace does if you get the exception.toString or the log message from Unity. Just these zeros. There's no way that we can get from this the actual line number to give you. And this is what it would, that same crash on Sentry looks like. So you get some useful information, but you get to the actual line of code. Okay, throw no at what line? Funny enough, this function has one line. So that would be an easy one. It's like an arrow and throw no. That's easy. Oops. So on mono JIT, you actually have the line numbers. It works if you get symbolicated. So if you're on Android and you choose to use mono and JIT, you could technically get line numbers. But now if you're on iOS, this is a limitation that crash reporting for Unity with ILTCPP just has today. So what can we do about this, right? So like we got crashes in all these platforms. They all will have no line number. It doesn't matter. There's nothing we can do. So we can ask Unity. You can say, hey, please give us line numbers. ILTCPP, we want line numbers. And there's a forum topic, people talking about this. I try to make a tiny URL so it's easier to, if you just want to type it in and no nag people. You can also tweet at the Unity folks. I've done that recently, just a few days ago. And they've said that for debugger, when the managed debugger is enabled in the Unity 2021, there will be line numbers for ILTCPP, which is really nice. So at least for the debug builds, but that doesn't help our production builds though. And they say they have no production, it's not production ready to hack your way and to get into the release builds, but looks like it's coming. So how do we get the stack traces from Unity errors in the first place? So if you know C#, you know the app domain.unhandle exception, that it's an event and it fires with an instance of an exception, and then you can expect the frames, and then there's a list of frames and you can get the line number from it if the PDB is available. But no, like Unity, of course, it gives you like a little event that gives you a string, and then you can parse the string. Like, why not? So this is an example of what some parsing code looks like, or just a little beginning of it. Basically, subscribe to this event and go crazy, do some string split and check if it has a parenthesis and so forth. And I said something about crashes, right? And crashes, well, let's go to native crashes first, and we can discuss this in more details. Because the way it works in Unity, it swallows all the errors for you. And you call a no reference that would crash an app, and if it wasn't handled, if you don't have a catch block, it would just crash the process generally, right? But on Unity, it doesn't. It's just Unity, traps this error and then logs it out. And if you don't have anything hooked up in production, this log goes nowhere, and it's just, you know, the button, the screen freezes and just nothing happens. So for native crashes, basically, you can have these native plugins. You can have a plugin on Android. You can have Java or Kotlin, and with NDK, you would have C and C++, Rust, Go, whatever you want. Actually, these are just examples. An Objective-C within Unity, you can throw an Objective-C file in iOS, right? Or an Objective-C++ file or a C file, and it also compiles with the editor and you know, into your Xcode project, and it just works at the end. It gets them bundled into the game. And with desktop, you can put shared libraries or C, C++, and console is the same. But there's more, right? So on Android, there's the Android native. So there's a virtual machine on Android as well. It's not ahead of time compiled by default anyway. You have the Java thread.uncaught exception. You could subscribe to that and get errors in it. With Bionic, which is this Linux thingy that Android has, is the, you know, with the NDK tooling gives you access. There are signal handlers that you can get these crashes, generate, either get a mini dump or just stack walk on the device. And from like if you're calling Java or Kotlin from C#, those exceptions, the Java exceptions are actually wrapped in a C# exception, and you can see it. The stack trace looks like Sentry thought it was a C# stack trace because it came from C#, but these are actually Unity wrapped into a C#. Well, it created a log, right? And we parsed the log into this. So this is an experimental thing. You can see it's not parsed at the device information there, operating system. And on iOS, there's a PL Crash Reporter bundled by Unity. So PL Crash Reporter is a library that today is maintained by Microsoft, and I have a typo there as reporter. And what it does, it creates a crash file and stores to disk. So Unity created a projection in C# that you can access this crash file programmatically. So for iOS, there's a solution. They only support this for iOS. PL Crash Reporter only works on iOS. Maybe Mac OS. I think Mac OS would work as well. Maybe Watch OS. I'm not sure. I'm pretty sure it works actually. But that's it, right? And then for other platforms, you don't have this option. There's no PL Crash Reporter there. For other platforms, there's Breakpad and Crashpad. These are Google libraries. They might not work everywhere because there are restrictions. Like Crashpad is out of process. Now you spawn a process that watches the main process. If the main process crashes, then it creates a mini dump from it, and we can upload such mini dump to Sentry. So Sentry supports all the individual platforms that we talked about and supports mini dump. So using Sentry as an example, this is one of the solutions. Yeah. So mini dump is kind of your last resort. It's the last bit. It's for native things. So you get a crash dump. It's just a minified representation of the memory space of that process, and then you have to stack walk on the server. When whatever processes this mini dump, you're going to have to like, okay, where were the stack in the first place of the threads, and to create a stack trace, and then symbolicate the stack trace to get the actual function names and line numbers and everything else. So it can get pretty complicated. Yeah, and this is all I have for you. So
cool. All right, thank you, Bruno, a lot for sharing what you discovered. And yeah, it kind of turned out to be a meetup focused on quality somehow. I hope you enjoyed it a lot. Thanks.
Well, thank you. And if anyone has any questions as well, I'm happy to answer.
Yeah, if nobody starts, I start. How do I integrate your SDK into Unity? Do you have a package, or is it just code I download, or?
Right. So the current SDK that Sentry has is a pure C#6 built for Unity. So it uses coroutines to send the event to Sentry and everything, which means it works everywhere in Unity 5.5 and forward and after. but it obviously has limitations. It doesn't store the event to disk in case of a hard crash, for example, and it doesn't capture native crashes that didn't go through the unit, that Unity didn't wrap.
Okay.
Right. So I started experimenting with the new SDK based on the .NET SDK. So I actually write C#9 and I compile that C#9 into an IL, like into a DLL. Like, so the output of my compilation spits out the DLL inside Unity, and then it just works there. And I put like some Unity editor windows so you can configure the SDK, things like this. And the first platform that I start targeting, so this will work like across the board for any C# error, it just works. But we're also looking into all this platform, all the cross-platform errors, right? So you want, if Android fails, if Unity fails to start on Android, we can capture that actually, and we can tell you. And we do that by bundling our Android SDK inside of Unity as well. So we have the .NET SDK and the Android SDK, and the Android SDK bundles the native SDK, which is written in C. So basically you have these three layers working together and capturing all sorts of, like, anything that can go wrong in the app. So the current SDK, it's a pure package. It's like a Unity package. You just throw it into your Unity project, and then some C# code shows up there. It compiles with your game. You can edit the files and have at it, and it just works. What we're working on, and then we're hiring someone to help with that or build that, take over and tell us what's the best way to do it or whatever. But the way that it works so far, I can build based on the .NET SDK, captures a wide range of different errors. It has a whole API for it to enrich the error with different context. You can put an attachment or send a user feedback. You want to prompt the user to input some text like, what was happening, capture this and send it with the error. There's a lot of things that the .NET SDK can add that the current unit SDK just doesn't have.
So in the app, I get a kind of crash pop-up, and then I can add code, and this is sent to you to your
so what the Sentry.NET SDK has is an API. So there's a method saying like capture user feedback, and you give the user feedback like a comment, email, and a name. But the UI would be up to you, right? Because everyone would want to make their own UI, so it would be a headache for us too. But yeah, this is one of the things. Attachment is another one. Attachment is not there yet, but it's coming really soon because the spec is already agreed on and the code is very straightforward to build. And we're building performance monitoring as well. Sentry has a whole performance monitoring product that is used by JavaScript already, Node, Python, PHP. I think Go is coming out. Java got merged, is coming soon. And .NET is coming soon as well in the next couple of months or something. It will be there. And then on Unity, you would be able to say start a transaction here and then add spans and then see the whole, how long the timing information of your of your transaction, whatever the transaction was for you in your game.
And Bruno, you showed some kind of dashboard. So is that like all these errors magically show up in my dashboard then?
Exactly, yeah. So Sentry, you add the SDK and the SDK instruments the app, it runs with the app. So in case of Unity, we hook to the logger and we capture all the log messages as, or at least this experimental SDK, all of the log messages as breadcrumbs. Sorry. So in an event of an error, we get the last X logs and ship it with the error, right? So you don't have just one line of error, you get all the errors that were happening right before the crash, leading up to the crash. And then Sentry can notify you that the error happened, say a Slack message, an email, or like a PagerDuty or whatever you use. There's a bunch of integrations. And these errors are grouped together, right? Based on the stack trace and some heuristics. So instead of getting spam for every error that happened in every customer, it's like a group of events will raise one alert and you get there and you can see, it affected 10,000 users or one user, and it will give you information like, is this happening only on Android 8? Is it an Android 9 problem? Because it has these tags that aggregate the error from different angles. So it's really useful to find the problem. So like it's very public because it's on the website. So I can mention like Riot Games, for example, uses this. I remember like interacting with the folks from there on GitHub about the SDK. So there are quite a few gaming companies. We also support Unreal Engine with a Crash Reporter endpoint. So yeah, but in Unity, we definitely want to improve the support with more native crashes support. That's why I've been looking into this, and that's why the talk. And the job ad is here, right? So it's also looking for someone to help us build this.
So what's the business model from Sentry then?
Yeah, so Sentry makes money out of the SaaS offer. So you can take it and run it for free on your company, for your business, that's fine. And a lot of companies do, like a lot. But we found that like for many, like, so first of all, you have a free tier, right? So for many are free. And then you have a team tier that's like $20 a month. Like how much does it cost for you to, maybe a VM is free, it doesn't matter, but how much of your time do you want to spend running servers? It's just, it's just very cheap. So people just put the credit card down and then they use the service, the SaaS service. So the business model is this, is by event volume. So the bigger the company, the more events they generate, the more they pay. And of course, there are more features. There are some features that are only for like business plan or, but I don't really know which features actually are on which plan. I don't know if that answered the question.
Yeah, sure. And a really cool talk. Thank you also, because it's showing like what's behind, right? So like the look under the hood, and it's like crazy. It's under the hood. It looks crazy as usually in all software. So it's
yeah, that's true. And yeah, and if you come from here from a C# point of view, and then you think this is C#, it's not at all, right? It's like that they even call it scripting C#. It's it looks like C#, but there's some constraints and there's some the runtime is different.
You have this shiny library you want to integrate, and then you realized it doesn't work.
Yeah, exactly.
So and then improved Sentry package or plugin for Unity. You don't know yet when it will be coming.
Yeah, so like the current one can still get improvements, right? We can still merge pull requests and ship improvements. So there's nothing wrong with it. We have millions of events coming with the current one. It's just we want to like create a new one. And so far, I'm the only one who put time into this. But I'm also working on the mobile team, and I get involved with iOS, Android, and like also with Java. And so time is split into other things. So that we don't have a timeline for the new SDK yet, but it's probably going to come in iterations because we want to focus on mobile first. If we're just doing .NET, like the C# layer plus Android plus Cocoa plus iOS, that's much easier than also doing web and also doing console and also. So we will focus on this first, and we already have an SDK. So our React Native SDK, for example, so it's a JavaScript SDK plus the iOS plus the Android plus the native. So we already have experience with bundling SDKs like that. So this will be just another one of these strategies of bundling SDKs.
Okay, cool.
Yeah, I really would like to have your last slides so I can help my memory. Is there a way that you can like?
Sure, I can share them later. I realized that one of the slides in the middle had some notes that I wanted to create slides from it. So I'll just delete that one, but it's still on the recording now, so it's gonna ruin it. Yeah, but sure, no problem. I'll do that.
Yes, please. Thank you.
All right. Yeah, I think that concludes the official part